Someone just spent $73 million on a company the internet says doesn't work. Every major battery company is targeting solid state by 2028. And a Hungarian scientist who spent 25 years being told her research was worthless just won the Nobel Prize. There's a pattern here.
There really is.
Yeah.
I mean, it's a profound, remarkably consistent pattern. And if you actually want to see it, you have to force yourself to look past the microscopic data of any single laboratory test.
Right.
You have to pull the camera way back and examine the macroscopic forces at play. Because we are talking about the structural forces of physics, the uncompromising realities of global economics, and honestly, the deeply entrenched institutional psychology that dictates whether a disruptive technology is allowed to breathe or whether it just gets smothered in the crib.
Which is, that's exactly our mission for this deep dive, because we are not here to endlessly litigate the granular voltage curves of another lab report today.
No, definitely not.
Like, if you are listening to this, you've probably already seen the debates raging across the forums and the comment sections. Instead, we are stepping back to examine the sociology of criticism. Today, we're mapping the industry trilemma, we're exploring the paradigm gap, and we're tracing the historical patterns of institutional resistance and narrative control.
Yeah, and we're using Donut Lab, alongside its upstream technology provider, CT Coding, as our real-time unfolding case study for this.
Exactly. Because, look, it is so incredibly easy to get lost in the weeds of capacity retention charts and completely miss the massive tectonic plates shifting right underneath the floorboards.
Right, because when you are standing dead center in the middle of a paradigm shift, it rarely looks like a clean, elegant scientific breakthrough.
No, it looks messy.
It looks incredibly messy. It looks like a controversy. It looks like, well, people yelling at each other on the internet. And to understand why this specific technology, this screen-printed solid-state battery architecture, faces such intense, almost visceral scrutiny from both the public and the legacy industry, we first have to understand the foundational physical laws that the entire global battery sector is fighting against.
The engineering bar.
Right. It's what chemical engineers call the battery trilemma.
So let's completely unpack this for you, the listener, because the trilemma is, well, it's the iron law of battery physics. It governs the device in your pocket and the electric vehicle in your driveway.
Yeah.
So imagine a triangle with 3 vertices. Vertex 1 is energy density. In plain terms, this dictates the physical weight of the battery and the range of a vehicle.
How far you can drive, basically.
Exactly. Then vertex 2 is fast charging. This is the speed metric, like how quickly you can violently pack energy back into the cell. And vertex 3 is cycle life. Longevity. It represents how many times you can charge and discharge that battery before it permanently degrades into just a useless brick. And the universally accepted consensus across the entire multi-billion-dollar industry is essentially this cruel joke of physics, right?
Mm-hmm.
You can pick 2 of those vertices, but you absolutely cannot have all 3.
You can't. It is a brutal zero-sum game of chemical engineering. And let's look at the mechanical why behind this, because I think it helps to visualize it. Think of a battery like a highly exclusive nightclub.
Okay, a nightclub.
Yeah. So energy density is simply how many people you can pack inside the building. To increase density, engineers have to pack more active chemical material into the cell and make the internal separating structures paper thin, which inherently makes the entire architecture fragile.
Right, so you've got a club packed wall to wall with people, and the walls themselves are literally made of glass.
Precisely. Yeah. Now introduce the second vertex, right? Fast charging. Fast charging is the equivalent of making the front doors of that glass nightclub incredibly wide and trying to shove 1,000 people through them in 5 minutes.
Oh, wow. Yeah, that's a disaster.
It is. When you force a massive amount of electrical current into that delicate, high-density internal structure, you generate immense heat and mechanical stress. Mm-hmm. The lithium ions literally crowd the interface, sometimes forming metallic spikes called dendrites. You physically tear the battery apart from the inside out.
Which completely destroys the third vertex.
Exactly, the cycle life. It destroys the condition of the nightclub after the party is over. Every major incumbent in the battery industry explicitly acknowledges this physical reality. They build their entire 10-year corporate strategies around mitigating it.
So let's ground this in reality and look at how the legacy giants actually navigate this triangle. Take Toyota and Samsung SDI.
Good examples, yeah.
They are pouring billions upon billions of dollars into next-generation solid-state batteries. But when you look at their engineering roadmaps, they have clearly chosen to prioritize energy density and cycle life.
Right, the first and third vertices.
Exactly. Like Toyota is publicly targeting 450 to 500 watt-hours per kilogram. To put that in perspective for you, a standard Tesla Model 3 battery sits around 260 watt-hours per kilogram. So Toyota is aiming to basically double the energy packed into the exact same physical weight.
Which is huge,
Yeah.
and Samsung is chasing what they call a 20-year lifespan.
Right. But to achieve that extreme density and that extreme longevity, they actively intentionally sacrifice fast charging. Their current solid-state prototypes simply cannot handle extreme rapid charging without that internal architecture degrading.
Right. And then, well, you look across the landscape to CATL, which is the largest battery manufacturer on the planet, and they take a completely different route to the trilemma.
They pick different vertices.
Exactly. They prioritize energy density and extreme fast charging. They're pushing what the industry calls 4C charging rates. The C stands for capacity, so 1C is a full charge in 1 hour. 4C means pushing a full charge in just 15 minutes.
Which is incredibly fast for a car.
It's blistering. But to get that speed, CATL openly admits their cycle life takes a massive hit. Their solid-state prototypes are currently hitting around 6,000 cycles. Now look, 6,000 is still a very impressive number for an electric vehicle, but it is a direct, calculated trade-off. They give up generational longevity to get that 15-minute charge time.
And then there's BYD. I mean, I find their approach so fascinating because it is purely pragmatic. BYD acknowledges the unforgiving nature of the trilemma so deeply that they don't even try to solve it in a single battery cell.
No, they split.
Literally. They split the problem across two entirely distinct product lines. They have a premium solid-state line designed purely for high density and high cycle life, targeting around 10,000 cycles. And then they have a completely separate, much cheaper sodium-ion line designed specifically for fast charging and low cost, but with much lower energy density.
BYD solves the physics test by mathematically separating the use cases and basically admitting defeat to the trilemma itself.
Right, which brings us directly to the outlier at the center of the storm. Because Donut Lab arrives on the scene and asserts quite publicly that they have shattered the trilemma entirely.
Yeah, shattered it.
They're claiming an energy density of 400 watt-hours per kilogram. They are claiming an 11C fast charging rate, which translates to going from 0 to fully charged in roughly 5 minutes.
5 minutes?
Yeah, and they are claiming an absolutely staggering 100,000 charge cycles.
And look, as if breaking the fundamental laws of battery engineering wasn't enough to invite internet skepticism, they stack claims that go far beyond the trilemma.
Yeah, the list goes on.
Right. They claim their manufacturing costs will fall below conventional lithium-ion. They claim zero lithium is used because it's sodium-based chemistry, making it completely green and non-toxic. They claim the battery is structurally stable and operable from negative 30 degrees Celsius all the way up to 100 degrees Celsius.
Which is a massive temperature window.
It's unheard of. And they claim inherent safety with no flammable liquid electrolytes, meaning the battery fundamentally cannot catch fire in a crash.
Right, so when you aggregate all of those claims into a single press release, I mean, it sounds indistinguishable from science fiction.
It does. It sounds fake.
Yeah. The trilemma is the physics test, right? But all those other claims are the engineering and commercial tests. But if we want to be genuinely analytical here, we have to isolate these claims and evaluate them individually against the current state of the art. Because, well, not all of them are actually that outrageous.
No, they really aren't. Let's do that. Take the 400 watt-hours per kilogram claim. The comment sections constantly fixate on this exact number as absolute proof of fraud, but 400 is actually just the industry direction.
Yeah.
That is exactly where Toyota, BYD, and Samsung are aiming for their 2027 to 2030 commercial targets. It's a high bar, yes, but it is not a uniquely extraordinary physics-breaking claim. It's simply the next generation's baseline.
Exactly. Even the fast charging at 11C, while wild, isn't totally alien. As we mentioned, CATL is already pushing extreme fast charge boundaries.
Right. The true outlier, the specific claim that shatters the predictive models and invites the accusations of fraud, is the 100,000 cycles.
Yeah.
Because if you look at the best-in-class targets across the entire industry, BYD is hoping to hit 10,000 cycles in their absolute best solid-state line. CATL is sitting at 6,000. Donut Lab is claiming a longevity that is 10 to 17 times higher than their largest competitor's most optimistic forward-looking target.
So the natural question you have to ask is, what empirical data actually exists to back up a claim of 100,000 cycles?
Well, this is where it gets tricky.
Right. When we look at the publicly available third-party reports, we only have short-run data. Back in 2021, Testing Lab in Germany ran these cells for 300 cycles at a 3C charge rate and reported zero degradation. And then more recently, in December 2024, the multinational testing firm SGS ran the cells for 100 cycles at 1C. And interestingly, in that SGS test, the capacity was actually still increasing.
Yeah, and we should probably explain that phenomenon for you because increasing capacity sounds like a violation of thermodynamics.
It sounds impossible, like the battery is magically creating energy.
Right, but it is actually a known quirk in some solid-state architectures. As the cell cycles early on, the internal solid interfaces, where the active materials literally meet the solid electrolyte, they begin to settle and optimize their contact area. This actually slightly increases the amount of energy the cell can hold before it eventually plateaus and begins its long, slow degradation phase.
Ah, okay. But the core issue remains here. 300 cycles in a German lab is a very, very long way from proving 100,000 cycles. We are completely missing a long-term degradation curve. If you plot a line graph, we basically only have the first millimeter of the line.
And this is where we run headfirst into the overstatement problem, which heavily pollutes this entire discourse. And frankly, both sides of the debate are deeply guilty of it.
How so?
Well, Donut Lab, operating under the intense pressure of a startup trying to secure funding and attention, uses maximum impact framing. They take their most extreme, optimal laboratory results from different isolated tests and present them in a unified marketing package.
Ah, right.
And the critics, in response, react with absolute categorical dismissal. They see a single unproven metric and declare the entire enterprise a fraudulent violation of physics. But there is an unconfirmed hypothesis floating around the engineering community right now that perfectly bridges this gap. It explains how Donut Lab can claim these trilemma-breaking numbers without necessarily falsifying their raw laboratory data. It's known as the multi-formulation hypothesis.
Walk me through this, because if you are trying to make sense of the math, this theory is the missing puzzle piece.
So, to understand the hypothesis, you have to understand that the foundational technology here isn't a single magical battery cell. The foundational technology is CT Coating's manufacturing platform, which prints a specialized nanopaste.
Right, the printer.
Exactly. The multi-formulation hypothesis suggests that CT Coating is not printing one universal super battery. Instead, their platform is capable of printing drastically different paste formulations, tailored for completely isolated use cases.
Give us an example of how that works in practice. Like, what does that look like?
Okay, imagine they print a cell using an organic cathode. Organic materials are incredibly flexible. They don't expand and contract violently during charging the way heavy metals do. So, a battery printed with this organic formulation might genuinely be capable of hitting 100,000 cycles without degrading, making it perfect for massive stationary grid storage where physical weight doesn't matter.
Right.
But the trade-off is that this specific organic cell might only have a low energy density of, say, 150 watt-hours per kilogram.
Okay, so they have a long-lasting, heavy battery for the power grid. What about the motorcycles, then?
Right, for a high-performance vehicle, they load a totally different paste into the printer.
Okay.
So this specific formulation might easily hit the 400 watt-hours per kilogram and the 11C fast charging required for a high-speed motorcycle. But it might only last 2,000 cycles before failing.
Let me stop you there, because the implication of this is massive. If this hypothesis is true, it means they're taking the 100,000 cycle life of their grid storage formulation, combining it with the 400 watt-hours per kilogram density of their performance formulation.
Yeah.
Taking the 11C charging speed of perhaps a third formulation and basically bundling all of those isolated peaks into one unified maximum impact public image.
Exactly. I mean, it is effectively the exact same strategy BYD uses when they build a solid-state line for density and a sodium line for speed. The difference is that BYD explicitly markets them as two separate products.
Ah.
The hypothesis here is that Donut Lab collapsed their separate formulation capabilities into a single confusing narrative. It stretches reality, not by falsifying laboratory data, but by aggregating physically incompatible specifications into a singular marketing identity.
Right. But hold on, I'm struggling with the baseline physics here. Even if they are printing different formulations and aggregating the marketing, they are still achieving isolated numbers, like a 5-minute charge time or an ambient temperature solid-state architecture that conventional multi-billion-dollar gigafactories are failing to achieve.
They are, yes.
So are they really accessing a new law of physics, or are they just cherry-picking their best lab days?
It is highly likely to be a consequence of the manufacturing process itself. The nanocase platform genuinely shifts the boundaries of what is mechanically possible. And to understand why, You have to understand how a conventional battery is made today.
Okay, let's bring that down.
Today's gigafactories use a process called slurry casting. They mix toxic chemical powders with a liquid solvent to create a slurry. They coat this slurry onto a metal foil, and then they have to dry it. And drying it requires feeding the foil through massive, energy-intensive thermal ovens that can be hundreds of meters long.
Hundreds of meters.
Oh yeah, it is a violent high-temperature process that takes hours and requires massive dry rooms with absolute zero humidity to prevent contamination.
And contrast that with what CT Coating and Donut Lab are doing with this printer.
Right, CT coating uses a completely different paradigm. It's ambient temperature screen printing followed by ultraviolet light curing.
So no ovens.
Exactly. Instead of baking a toxic slurry in a massive thermal oven, they print a solvent-free paste at room temperature and just expose it to a flash of UV light. The polymer composite cures and hardens in seconds.
Wow.
And this gentle, rapid curing completely alters the physical structure of the electrolyte. It creates an incredibly pristine, tightly bonded interface between the anode and the cathode that traditional thermal baking literally cannot replicate.
And what does that pristine interface actually do?
That pristine interface reduces internal electrical resistance, which is exactly the mechanical mechanism required to allow an 11C fast charge without generating that battery-destroying heat we talked about. So the manufacturing process itself may genuinely shift the boundary of the trilemma, even if the 100,000 cycle claim only applies to a very specific, heavy formulation.
Which brings us to the most common, probably the loudest question you see on every single forum discussing this tech.
Oh, I know the one.
Right. If the battery specs like the 400 watt-hours per kilogram are simply the industry standard for 2028, and if the chemistry isn't fundamentally violating thermodynamics but just leveraging a better manufacturing technique, why hasn't a legacy giant like Toyota or Volkswagen just swooped in, written a massive check, and licensed this technology?
Right.
And this leads us directly into what we have to call the paradigm gap.
The paradigm gap is perhaps the most misunderstood element of this entire saga. You really have to clarify for the listener that Toyota, Samsung, BYD, and CATL are all targeting solid-state chemistry for the end of the decade.
Everyone is doing it.
Everyone. The chemistry itself moving from a liquid to a solid is not the true differentiator here.
Right.
Everyone knows solid state is the future. The actual disruption, the real innovation that is hiding in plain sight behind all the noisy battery specs is the CT coating manufacturing platform itself.
Right, it's the printer. Like, we get so obsessed with the specifications of the battery that we completely ignore the machine making the battery. We are talking about replacing a billion-dollar, miles-long gigafactory filled with toxic slurry mixers, massive dry rooms, and immense thermal baking ovens with a screen printing line that operates at room temperature.
It's a fundamental shift.
And the capital expenditure to set up a CT coating production line is roughly 20 million euros. You are comparing a 20 million euro printer to a 2 billion euro gigafactory. The economics are just staggering.
And this manufacturing vision, by the way, is not a sudden, desperate pivot by a failing startup. If you dig into the history, you find incredibly deep, entrenched roots. There is a publicly available LinkedIn post from 2010 written by Enrico Goldman, who served as the director of business development for CT Coating.
2010.
16 years ago, long before the current EV boom, he was publicly outlining their roadmap. He stated they were targeting sodium-ion chemistries, ceramic battery architectures, green printing production methods, and lifespans of hundreds of thousands of cycles.
That is wild when you think about it.
It is. The exact, highly specific claims that Donut Lab is making today were explicitly laid out as an engineering target 16 years ago.
16 years of dedicated development on this specific printing technique. And yet, if you look up CT Coating today as a corporate entity, they only have roughly 4 to 5 core employees and generate around 20 million euros in revenue.
Right.
And the internet commentators look at that headcount and immediately scream, aha, fraud. How can a 5-person company in Germany revolutionize the entire global battery industry when CATL has thousands of engineers?
They screen fraud because they are fundamentally misinterpreting the business model of an IP holding company. CT Coating is not, and has never tried to be, a mass manufacturer of batteries.
Right.
They are an intellectual property and platform company. They formulate the chemical recipes for the nanopaste, and they design the architectural blueprints for the printing process.
It requires a tech analogy to really grasp. Looking at CT Coating with its 5 employees and asking why they aren't physically building multi-gigawatt-hour battery factories is a total category error. It is like looking at ARM, the company based in the UK that designs the underlying architecture for almost every single mobile smartphone processor on Earth, and demanding to know why ARM doesn't physically manufacture their own smartphones.
Right, they don't make the phones.
ARM designs the blueprint. Companies like Apple and Qualcomm license it and build the actual chips. CT Coding designs the paste and the printer. Their partners are supposed to build the batteries.
Exactly. But that analogy still leaves us with the critical question. If the blueprint is so revolutionary, why haven't the big automotive OEMs, the original equipment manufacturers like Ford or Toyota, licensed it?
Right, why not?
To understand this, we have to walk through what industry insiders call the 5 shields. These are the 5 structural, psychological, and logistical reasons why this technology hasn't been swallowed whole by a legacy giant.
Okay, let's break down these shields because they explain so much about how corporate innovation actually works, or rather, how it fails to work. Shield 1 is the due diligence wall.
Right. CT coding operates on an incredibly strict trade secret posture. They purposefully do not patent the exact chemical compositions of their nanopaste.
Because patents are public.
Exactly.
Yeah.
A patent requires public disclosure. You have to tell the government exactly how it works. In the cutthroat battery industry, public disclosure instantly invites massive competitors in China or the US to engineer slight chemical workarounds and steal the core concept without technically violating the patent.
Ah, so they keep it secret.
Instead, CT coding relies on perpetual non-disclosure agreements, keeping the recipe locked in a vault. But for a massive conservative corporation like Toyota to evaluate licensing and technology, their legal and engineering teams require standard corporate due diligence.
Sure.
They demand to see the recipe to verify it works. CT coding refuses to show the recipe without guarantees. The corporate evaluation process simply hits a wall and halts.
Which leads right into Shield 2. The not invented here syndrome combined with massive sunk cost. Toyota isn't just sitting around in Japan waiting for someone to hand them a solid-state battery.
No, they are heavily invested.
They're already $14 billion deep into their own in-house, sulfide-based, solid-state battery program. They have thousands of engineers who have spent a decade working on sulfide chemistry. To pivot away from that and license a radical screen printing platform from a 5-person German firm requires an executive at Toyota to walk into a boardroom and admit that their $14 billion decade-long investment might be the wrong path.
And corporate psychology simply does not allow for that level of ego destruction easily.
No, it doesn't.
The institutional inertia is overwhelming. And if they did want to pivot, they would hit Shield 3, the captive licensee model. As we establish, CT coding scales through a decentralized partner network. They license the printer and the paste to regional independent entities like Nordic Nano and Donut Lab in Finland.
Right.
The legacy auto industry does not know how to interact with a decentralized, highly compartmentalized supply chain of small startups. An automaker like Volkswagen wants to sign a contract with a massive supplier like Panasonic or LG, who can absolutely guarantee a gigawatt hour of output from a single centralized facility.
Right. They view a network of decentralized printers as a massive supply chain risk.
Exactly. And even if an automaker was willing to take that supply chain risk, they run straight into Shield 4, which is the TRL gap, the technology readiness level gap.
Let's define that. For you listening, TRL is a measurement system originally developed by NASA to assess how close a new technology is to actual real-world deployment. TRL-1 is basic theoretical research. TRL-9 is a flight-proven, ready-to-launch system.
Exactly. And the gap here is massive. What CT Coding and Donut Lab have historically produced are lab-tested pouch cells. A pouch cell looks basically like a vacuum-sealed silver coffee bag. It's a single unit of energy. We can classify that as roughly TRL-5. But an automaker doesn't buy pouch cells. They buy an automotive-qualified pack-integrated module, which is TRL-8 or 9.
That's a huge leap.
It is. Moving from a single silver pouch to a rigid, crash-tested 800-volt module requires designing complex battery management systems, integrated thermal cooling plates, and structural safety casings. There's a massive, highly expensive engineering valley of death between a working lab cell and a drivable car battery. Big OEMs refuse to license the pouch cell. They want the fully validated automotive component.
But that valley of death finally brings us to Shield 5, which is actually the strategic solution to the first 4 shields. It's what we call the Holyvolt bridge.
Ah, yes, Holyvolt.
Enter a company called Holyvolt AB. This is the Swedish entity within the CT coding licensing network, and their specific mandate is to scale the technology across that valley of death. And they aren't a small startup. They have incredibly heavy-hitting institutional backing, including direct investment money from Volvo and the Wallenberg family, who are essentially the industrial royalty of Sweden.
And this institutional backing culminated in March of 2026 with a massive, undeniable financial move. Holyvolt acquired a company called Wildcat Discovery Technologies for $73 million.
$73 million.
Yeah. And you have to understand, Wildcat isn't just some empty shell company used for financial maneuvering. They are an elite, AI-driven materials discovery company based in San Diego, and they were founded by Peter Schultz, the CEO of Scripps Research.
Wow.
This acquisition completely alters the gravity of the entire situation.
Let's explain why this matters mechanically. How does AI materials discovery actually change the equation for this printed battery?
Well, traditional material science is painfully slow. A graduate student mixes a chemical variation of a battery cathode, builds a cell, tests it for a week, and records the data. It takes years to optimize a recipe.
Very manual.
Extremely. Wildcat Discovery uses high-throughput robotic laboratories guided by artificial intelligence. The AI suggests a molecular recipe, robotic arms physically mix that specific nanopaste, prints a test cell, run electrical current through it, and feed the performance data back into the machine learning algorithm thousands of times a day.
So they automate the trial and error.
Exactly. They systematically map the entire chemical landscape. By acquiring Wildcat, the Holyvolt network can take CT Coating's baseline paste formulations and use this robotic AI lab to rapidly find the optimal automotive-grade chemistry required to cross that TRL gap. It brings undeniable, serious institutional scientific credibility to a network that was previously defined by extreme secrecy and small headcounts. And this is the moment where the paradigm gap transitions into something far more profound. Because the intense disbelief surrounding Donut Lab and CT coding isn't a unique internet phenomenon. In fact, the exact way these legacy institutions and the public are reacting follows one of the most well-documented patterns in the history of science.
This is where we have to look at the historical mirrors. If you study the history of science, you quickly realize that institutional resistance isn't an anomaly. It is practically a law of nature when it comes to paradigm shifts. The establishment never welcomes disruption with open arms. Let's look at Mirror 1, Katalin Kariko, and her work on mRNA technology.
Katalin Kariko's story is profoundly illustrative of this exact dynamic. She spent 25 years facing near-total, soul-crushing rejection from the biomedical establishment.
25 years?
Yes. In 1995, the resistance was so fierce that she was actually demoted from her tenure-track position at the University of Pennsylvania. Her colleagues, the peer reviewers, and the grant funding boards repeatedly told her that mRNA was too unstable to ever work as a therapeutic in humans.
Why did they think it was unstable? Like, what was the mechanical argument there?
The biological dogma of the time was that the human body's immune system is designed to destroy foreign RNA instantly. The moment you inject synthetic mRNA, enzymes in the bloodstream rip it apart before it can reach a cell to deliver its instructions. The entire establishment considered it a biological dead end. They told her to stop wasting university resources. Yet, her quiet, decades-long persistence in figuring out how to package that mRNA in a lipid nanoparticle eventually led to the foundational technology for the COVID-19 vaccines, saving billions of lives. The scientific community that demoted her in 1995 had to watch her win the Nobel Prize in Medicine in 2023.
And we must explicitly bridge this back to the subject of our deep dive today, because the parallel is not just close, it is exact. The medical establishment telling Kariko that mRNA is fundamentally too unstable is the exact verbatim institutional equivalent of the legacy battery industry telling Donut Lab that sodium can't ever match lithium energy density.
Exactly.
Both statements were treated by the establishment as unbreakable laws of physics. In reality, they were simply very difficult, entirely solvable engineering packaging problems. And crucially, both innovators were challenging entrenched billion-dollar legacy industries. For Kariko, her work threatened the established DNA gene therapy complex. For Donut Lab, they're threatening the multi-billion-dollar lithium-ion gigafactory complex.
The pattern repeats itself relentlessly. If we look at Mirror 2, the dynamic reinforces itself. Consider Dr. Barry Marshall and his revolutionary work on Helicobacter pylori.
Oh, this is a wild story.
It is. For 12 agonizing years, Marshall faced total, mocking rejection from an $8 billion global antacid industry. The established, unquestionable medical dogma of the 1980s insisted that the human stomach was a sterile environment because of gastric acid.
Right.
Therefore, no bacteria could possibly survive there. Ulcers, the establishment declared, were caused by stress and spicy food. End of story. The prescription was to take expensive antacid pills for the rest of your life.
And the resistance Marshall faced was so absolute, his inability to get a fair hearing in peer-reviewed journals so complete, that he resorted to an act of sheer desperation. He famously took a beaker of meat broth swirling with live H. pylori bacteria,
He drank it himself.
literally drank it. He intentionally developed severe gastritis and then had his own stomach biopsy to prove the bacteria survived and caused the disease. He essentially had to poison himself to bypass the institutional denial, and for that, he won the Nobel Prize in 2005.
And again, we must bridge this back to the modern battery industry. The resistance Barry Marshall faced wasn't driven by some cartoon villain malice where doctors secretly wanted ulcer patients to suffer.
No.
It was driven by institutional logic. They were protecting massive legacy investments in a treatment paradigm antacids that worked reasonably well and generated billions of dollars in recurring revenue. The lithium battery industry is operating on that exact same institutional logic today.
Right. They have optimized lithium-ion manufacturing to an incredible, highly profitable degree. Why on earth would they entertain a radical, untested screen printing sodium alternative when they have just spent 3 decades perfecting the current supply chain?
They wouldn't. And this institutional logic predictably generates what sociologists call the shifting goalposts framework. When a radical disruption threatens an incumbent industry, the denial doesn't happen all at once. It goes through 4 distinct, highly predictable phases.
Walk us through the phases.
Phase 1 is the declaration of physical impossibility. The physics don't work, this is a total fraud. Phase 2 is the scaling objection. Okay, fine, it works in a tiny lab beaker, but it can never scale to mass commercial production.
Right, the factory argument.
Yeah, phase 3 is the economic objection. Okay, you scaled it, but it's far too expensive and the global supply chain isn't ready for it. And finally, phase 4 is revisionist history. We knew it all along, it was inevitable, we were always supporters.
We've seen this exact progression play out in recent memory. Solar power went through all 4 phases. When solar was first proposed for grid scale, executives laughed and said it violated the economics of energy density. Lithium-ion itself went through all 4 phases when it challenged the dominant nickel-cadmium batteries in the 1990s.
And if we look at CT coding, they have been trapped in phase 1 for 16 long years. Donut Lab is currently navigating phase 1 in real time, completely exposed to the internet. Every forum thread is filled with people screaming that the chemistry is thermodynamically impossible.
And while the public is screaming that it is impossible, the massive corporations are engaging in a fascinating, deeply hypocritical dual-track reality. Donut Lab's CEO, Marco Letamecki, observed this explicitly in recent interviews.
Oh, this is my favorite part of the whole dynamic.
It's so telling. He noted that massive legacy corporations will attack Donut Lab publicly. They use their PR teams and affiliated academics to issue statements declaring that the technology is unproven, risky, or outright impossible. But simultaneously, the venture capital arms of those exact same legacy corporations are calling Donut Lab privately, trying to secure early investment allocations.
It's the ultimate display of corporate cognitive dissonance. But it makes perfect, ruthless sense if you understand the institutional logic. Look at the history of Kodak.
Right, the digital camera.
Kodak literally invented the first digital camera prototype in the 1970s. They suppressed it and publicly downplayed digital photography to protect their incredibly lucrative chemical film revenue, while secretly trying to figure out how to transition their business model behind closed doors.
Or IBM.
Exactly. IBM executives publicly dismissed the concept of personal computers as mere toys for hobbyists, while they secretly built the IBM PC in a heavily guarded lab in Boca Raton, Florida. It is entirely rational behavior for a complex corporate organism to publicly protect its current cash cow while privately hedging its bets against an existential threat.
However, we have to remain entirely analytical here. There is a vital caveat to this entire historical pattern that we absolutely must address. Being rejected by the scientific establishment does not automatically mean the outsider is a misunderstood genius.
No, absolutely not.
Sometimes the establishment is right and the outsider is just wrong. We have to look at the spectacular failures. In 1989, Pons and Fleischmann held a press conference announcing cold fusion limitless energy in a jar at room temperature. They were ruthlessly rejected by the physics establishment, and in their case, the establishment was entirely correct.
The experimental claims collapsed under rigorous scrutiny.
Right. And then, of course, there is Theranos, which claimed to revolutionize blood testing with a single drop of blood. That was a massive, multi-billion-dollar criminal fraud.
The Theranos comparison is critical. Whenever a hardware startup makes wild, paradigm-shifting claims today, the internet immediately screams, It's the next Theranos. It has become a reflex. But we have to look at the structural differentiator between a fraud and a breakthrough.
What's the main difference here?
Well, Elizabeth Holmes's entire operational strategy at Theranos was built on absolute darkness. She kept the Edison blood testing machines hidden in secret rooms. She systematically, aggressively avoided any independent, third-party scientific testing. She used corporate lawyers to threaten anyone who asked for raw data.
And this is exactly where Donut Lab is doing the polar opposite of the Theranos playbook. Donut Lab isn't hiding their cells in a dark room. They're literally taking their battery cells, handing them over to the Finnish government's premier independent research laboratory, VTT, as well as international testing giants like SGS. They are letting these third parties run the cycle tests, and then Donut Lab is taking the resulting raw data reports and posting them online for completely unrestricted public scrutiny. You cannot call them Theranos when they are proactively inviting the very scrutiny that Theranos spent millions of dollars trying to avoid.
It is the defining differentiator. Rejection alone tells us nothing about the validity of a technology.
Yeah.
But proactively inviting rigorous, independent verification tells us everything about the company's internal confidence. But, ironically, that unprecedented sharing of raw data brings us to a very modern, very unique problem.
Right.
When you proactively open the door just a crack to the internet immediately demands that you take the entire house off its hinges. This introduces the incredibly volatile dynamic of transparency and social pressure.
Oh, this is where the sociology of criticism gets truly wild. Let's examine the NDA paradox. Donut Lab, as a licensee, is legally bound by CT Coding's perpetual non-disclosure agreements.
Which makes sense for their business model.
Right, but the paradox is this. The actual material scientists and engineers who know the exact chemical composition of the nanopaste, the people who actually understand the physics, cannot speak publicly because they will be sued into oblivion. Meanwhile, the people who are speaking the loudest, the internet commentators, the Reddit engineers, the YouTube analysts, don't actually know the chemistry.
It creates an information vacuum filled entirely by speculation. And you have to point out to the listener how incredibly historically rare it is for a pre-revenue, deep-tech battery startup to proactively open its mid-development testing data to the public in the first place.
It never happens.
It really doesn't. Usually, hardware companies operate in total stealth mode. They keep everything entirely locked down behind corporate firewalls until the final product officially launches. Or they only release data reactively to fight off a coordinated short seller attack on their stock. Donut Lab volunteered this VTT data. But because that single data report doesn't answer every single theoretical question simultaneously, it breeds intense vitriolic frustration among the public.
Which directly leads to audience social pressure. There's a fascinating quote from the popular technology YouTuber 2Bit Da Vinci while he was reviewing one of the VTT reports on Donut Lab. He looks at the camera and essentially says, "If the next test is as lightweight as this one was, we might not even cover it." That is a brilliant, entirely modern sociological tactic.
It is the only tool the audience has left in their arsenal. The general public has absolutely zero legal, financial, or contractual leverage to force a private company to reveal its heavily guarded trade secrets. You can't sue them for the recipe.
Right.
Therefore, to force disclosure, the internet uses the only currency it controls: social pressure and attention. They threaten to tune out, or they frame the company negatively in the algorithm, essentially sending a message: give us the comprehensive data on our timeline, prove it to us right now, or we will declare you a fraud and destroy your public reputation.
But the reality of hardware engineering is that Donut Lab doesn't owe anyone on a forum data on an internet timeline. Hardware moves at the speed of physics, not the speed of a Twitter feed. Which is why we have to bring this entire expansive discussion back to the ultimate, inescapable consistency check. The physical product.
The motorcycle.
Yes, the Verge TS Pro motorcycle, which is slated to use these batteries, is scheduled to ship to real-world customers in spring 2026.
The timeline is the ultimate judge. If these motorcycles are shipping to consumers with production-level battery packs in spring 2026, then the cells currently being tested right now at the VTT labs must be production representative. The engineering timeline dictates it.
You can't fake a shipping product.
No, you can't. The common internet excuse of, well, it's just an early hand-built prototype that doesn't prove anything, is rapidly running out of time. If a physical vehicle goes to market, the theoretical debates end permanently, and real-world performance data takes over.
So as we look at this entire landscape, I want to ask you, the listener, a direct question. We feel entitled to see the raw chemical data on our own aggressive timelines because we have been completely conditioned by the instant transparency of software and the internet. But are we holding a scrappy startup like Donut Lab to a brutal standard of transparency that we don't demand from Toyota or QuantumScape or CATL simply because Donut Lab chose to engage with us on YouTube?
It's a fair question.
I mean, Toyota doesn't post their mid-development failure rates on Reddit. Why do we demand that Donut Lab does?
It is a profound double standard.
Yeah.
And it perfectly highlights the intense friction between the slow, methodical timelines of industrial research and development and the hyper-accelerated speed of internet consumption.
So, as we wrap up this deep dive, I want to leave you with a broader, perhaps slightly unsettling philosophical question to ponder on your own. We've spent this time mapping the trilemma, understanding the paradigm gap of manufacturing, and looking at the historical mirrors of Kariko and Marshall. Think about this deeply. In a modern world where the massive legacy institutions evaluating a scientific breakthrough have literally billions of dollars in sunk costs riding on that breakthrough being false, how can society ever accurately recognize a genuine paradigm shift when it finally arrives? The gauntlet has been thrown, a $73 million bet placed. Kariko waited 25 years, Marshall 12, CT coding 16 and counting.